5.6b, we're going to be finding inverses of linear functions just as we did in the last lesson, but this time we're going to be graphing them. So what I want to do is just kind of review how do you graph a line. And so we have graph y equals negative 1/3 x plus 4. So pause the video to see if you remember how to graph it first. So hopefully you tried it out and were able to graph these. First, you need to identify, so y equals mx plus b. We identify the slope, and the slope is next to that x value, right? So it's our m. And so we can write that as negative 1/3 or 1/-3. It's the same thing. Now, the reason why I do that is because remember that slope is rise over run, rise over run. And so with the top number, if it's positive, we're going to go up. If that number is negative, we go down. Now with the run, if it's positive, we're going to go to the right. If it's negative, it's going to go to the left. So writing it in these two ways will kind of help remind us of which way to move. Now the b is our y-intercept. So y-intercept is the constant at the end. So the y-intercept, or when x is 0, right? Y-intercept is when x is 0. So if you plug in 0 for x, we would find that it's 4. So 0, 4. So when graphing lines, you begin with the y-intercept. So that is at 0, 4. And then we move with slope. So starting at our y-intercept at 0, 4, we can go negative 1/3. That tells me I can go down 1 because it's negative 1. Positive 3 is right 3. So down 1, right 3. Or I can start from the point on the y-intercept again. Positive 1 is up 1 and then left 3. And then here is our line. So let's try this next example just to kind of remind us of how to graph y equals 2x. So think about y equals mx plus b. So our slope is 2. Now there's no number underneath it. Now remember there's always an invisible number underneath. It's a 1, so it's 2/1, so it's positive. Or we can say it's negative 2 or over negative 1, because remember negative over a negative is a positive. Our y-intercept, so there isn't a number back here, but remember that the y-intercept is when x is 0. So if we plug in 0 for x here, plug in 0 here, 2 times 0 is 0, so it's just 0. So that's one way to find it. If you see no constant, it's just 0. So we can graph this starting at the y-intercept of 0, 0. Then we can go up 2 because it's positive, right 1 because it's positive, and continue. Or from that origin again, we can go down 2 because it's negative 2 and left 1 because it's negative. And that's still a positive slope. Remember, with a positive slope, it goes up from left to right. Now let's talk a little bit about inverses and how they're related with their table and graphically. So on the left side, we have 4x plus 3 and x minus 3 over 4. And so there's something you can kind of notice about the tables. So we have negative 2, negative 1, 0, 1, and 2, negative 5, negative 1, 3, 7, and 11. Notice that for g of x here, that our x values are the y values for our g of x. And then the y values for f of x are now our x values for our g of x. So what happens in both of these is that the x's and the y's are switched. And so think about when we find inverses of functions, if you did the last video, after we change f of x to y, we always switch the roles of x and y. And notice that that's what happens here graphically. So if I were to label this point here, this is 3, 0. This point up here is 0, 3. So it would be true for all of these points. So this would be negative 2, negative 5, and up here would be negative 5, negative 2. All of those values are switched. So x, so what do you notice about the tables? X and y values are flipped or switched. Always for our inverse functions. And the same thing here for our radical and our square root. So notice that the x values are the y values for the radical, and the x values for our g of x is our y values for our f of x. So those are flipped. Also notice there's this line here, this green line. So what do we notice about the graphs? They're all reflected across this line called the line of reflection. That line of reflection is y equals x. So each of those graphs are reflected across that line. Now talking about the x squared, our parabola here, so remember that looks like a u. Now it says that x has to be greater than or equal to 0, meaning we only want the right side of the parabola. So notice that I only take the right side of the parabola here, and we're disregarding the left side, right? Because if the left side existed, it wouldn't be exactly mirrored to the blue one, right? To our radical graph. So we have to restrict it so that way they look exactly mirrored across that line of reflection. So now what we're going to do is we're going to go ahead and find the inverse of this function here. F of x equals 1/3 x minus 1. And so we did that previously in the other lesson. And so the very first thing we want to do is to change f of x to y. Y equals 1/3 x minus 1. Then we switch the roles of x and y. Now we solve for y. So let's add 1 to both sides. We get x plus 1 equals 1/3 y. Then to get y by itself, we're going to multiply 3 to both sides, remembering to distribute to everything on the left. So this becomes 3x plus 3 equals y. And then remember we write that as g of x equals 3x plus 3. So now we find the inverse and we're going to graph both. So I'll go ahead and graph the g of x first, 3x plus 3. So we start at the y-intercept of 3 and use the slope of 3 over 1. So I can go down 3 left 1. That's what fits on my graph. And it's important to label it. So this is our g of x. Let's graph our f of x. So that starts at -1, and the slope is up 1, right 3, or down 1, left 3. And I'll label that. That is our f of x. And let's go ahead and also graph our line of reflection, which is y equals x. Y equals x. Now y equals x, if you think about it, that has it can start at 0, 0, or y-intercept is 0, 0, and then the slope is up 1, right 1. So you can just draw that diagonal line through. And notice that they intersect, all 3 lines intersect on that line of reflection. So that's really, really important. If for some reason your graphs do not intersect on that line of reflection, number 1, check the algebra to make sure that something didn't happen. Maybe you forgot to distribute. It may be that it's not an inverse, but for purposes of the examples we have here, they're all going to be inverses and they all should work. So they should all intersect on that line of reflection, just like it does here. So here are 3 examples for you to try. So number 1 and 2, and then number 3 is letter A. I skipped that one. That one's a little bit tougher to graph. So if you are adventurous and want to try to graph that, go ahead and try that as well. So pause the video and try these out. So find the inverse and then graph both, including that line of reflection. So on the right side, you should have gotten g of x equals 5x plus 5. So remember to distribute. So then I start with the graph. I start at +5. The slope is 5, 1. So I can go down 5, left 1, down 5, left 1. That is my g of x. Then f of x, I start at -1. The slope is up 1, right 5. I do my line of reflection, making sure to label everything. And so they definitely intersect at that line of reflection here. And it's not always on a grid line, right? They still hit, and that's perfect. They all converge at that line or meet at that line. Number 2, you should have gotten g of x equals 2x minus 4. And so here is the graph as well. For letter A, you should have gotten the inverse of 2x minus 5. So after you switch the roles of x and y, then you multiply both sides by 2, so it's just 2x, subtract 5, so you get 2x minus 5. Now that one's fast to graph, you start at -5 and use the slope. Now this one's a little bit tougher. You want to be able to start at a nice grid line. Now remember, you can always plug in a number. So you can plug in, like I chose 1, for example, because I know if I add 1 and 5, that'll get me 6, and that divides nicely with 2, right? 2 goes into 6 really nicely. So then I get the point 1, 3. So just pick a number that works out really nicely. So I have 1, 3. Then what we could use is the slope to finish graphing. So remember, this is x plus 5 over 2. We could split it up. It's really 1/2 x plus 5 halves, right? So x over 2 is the same as a half. So just kind of splitting it up just so you can read the slope. So again, with problems like these, just pick a number that works out really nicely. When you add them, subtract them, and then from there, just use slope.